All right, everybody, thanks for coming out. Like you said, my name is Tyler Sanderson. I'm a front-end developer from here at Improving. Today I'm going to talk a little bit about web application security. So here's my agenda. Go over the OWASP top 10 list, what that is. I picked 5 specific vulnerabilities that we'll look at kind of at a high level. Cross-site scripting, cross-site request forgery, SQL injection, clickjacking, tab nabbing. We'll look at those, how they work at a high level, and then we'll really focus on how to prevent these. Because really the meat of what we're talking about is secure application configuration, how do we secure our apps, and we'll talk about how content security policies, cookies, good best practices with cookies, I should say, cores, headers, and best practices around framing can help secure our apps from various vulnerabilities like the 5 I'm going to talk about, but also others. And then we'll close talking about some tools we can use to help us keep our applications secure, and then some recommended resources. Quick plug for my employer, Improving. We are a modern digital services company. We have expertise front-end, back-end, cloud, AI. Have an office right here that you're in here in Omaha. Also a lot of offices around the country and now in South America as well. Let's see here. Got over 1,800 consultants and over $247 million in revenue last year. 18 offices, here's our 18 offices, and I believe we've added one since this slide was published. But yeah, all over Canada, United States, Mexico, and now South America as well. If you have any questions about that, feel free to reach out. Okay, the OWASP top 10. So when you're looking at specifically web application vulnerabilities, OWASP is probably one of the best resources to look at. They're the Open Worldwide Application Security Project, so a nonprofit around keeping the web secure. One of the big things they put out a lot of community-led projects, a lot of good resources out there that are totally free. But one of the big ones, probably the most widely cited, is the OWASP top 10 list. So this is a list of vulnerabilities they put out every 4 years. A lot of research and data kind of crunching goes into it, and they come out with a list of the top 10 web vulnerabilities we need to be watching out for. So if you're looking for what are the biggest things you need to secure your web applications against, this is a good first start because there's a lot of surveys with security professionals and things like that. So they publish this every 4 years. The last one was in 2021. They said they were planning on publishing the next one in the first half of 2025. So I don't know if that's going to happen because we only got a few days left of that. So I was hoping it'd be out before I gave this talk, but we'll look at the 2021 list because this is the most recent list we have. So at the top we have broken access control. So people being able to access resources they shouldn't be able to. And one of the examples of that is cross-site request forgery, which we'll get into. 2 cryptographic failures, so either missing encryption or weak encryption. Number 3 is all forms of injection. That includes cross-site scripting and SQL injection, which we'll talk about. Number 4 is kind of a general category around insecure design, but an example of that would be allowing a password reset without verifying the user is who they say they are. Number 5, security misconfiguration. So example like that, missing headers or not having a strong content security policy. And we'll talk about those. Number 6, vulnerable or outdated components. So most of our apps are built on top of various open source libraries and packages. And if those remain outdated or unpatched, those lead to vulnerabilities. Number 7, identification and authentication failures. So weak authentication mechanisms like lack of 2-factor. Number 8, software and data integrity failures. So not validating like an update hash, for example, or even the SolarWinds hack of 2020 falls into that category. That's where they had their pipeline. The hackers were able to get inside the pipeline and then inject code into the app that way, I believe. So a hack like that would also fall under this category. Number 9, just poor logging or missing logging or monitoring failures. So you're not able to detect breaches, or if you do, then you don't have the data to fully track them down. And then number 10 was a new one added in 2021, server-side request forgery. This is where a hacker might trick the server into making a request that you wouldn't be able to on the front end. So if your server's in like a VPN, if you can trick the server into making a request to something it has access to and returning you the data, that would be a server-side request forgery attack. All right, so the first one we'll look into is cross-site scripting. So cross-site scripting is when somebody is able to get JavaScript that you didn't write running on your app. So if they're able to inject their code into your app, they can do a lot of malicious things. So if someone's able to do this, they can steal session tokens, they have access to the data that it's in scope, credit card information, maybe they install a keylogger and then they get the user's password when they log in, or they can redirect to a malicious site. There's a lot of things that can be done with cross-site scripting. There's a couple different methods to do this. The two main ones are reflected and stored cross-site scripting, and we'll look at some examples of this. So in the stored cross-site scripting case, the hacker would inject their malicious code. Somehow they'd get it into your database. So whether that's through SQL injection or some other means, they're able to get their JavaScript into your database, the database that's used to create your application. So the next time a page is generated, it's pulling from that database and it's injecting that code on the page. So then when a user visits your application, their JavaScript is now running when they open your web page. That's the stored cross-site scripting case. And that's particularly harmful because this could impact every single user that visits your site if they're all seeing the same page. The reflected case is a bit easier to see with an example. So I have a simple example here. So imagine this is a search box. You're maybe e-commerce application, you're going to search for various products. You search for a product, right? And then it does the search, and maybe it says, hey, you searched for this product, and it displays it on the screen. Well, if you were to insert something, here's the most basic cross-site scripting example. Okay, well now I inserted a script tag into the DOM. So the attacker would do something like this, where they're able to insert a script tag, and then once the page is generated using that user input, if it's not sanitized, then it'll get injected into the document and run that script. In this case, it's pretty harmless. I'm just running an alert and showing an alert box, but an attacker could, with the same method, reach in and maybe grab a session token from a cookie, for example. And then it's just one more step to send it to their web server. Now they have your session token, are able to take over your account. Another easier thing they could do is another payload like this, run some JavaScript to then redirect them to the hacker's website, for example. So a lot of things that an attacker can do with cross-site scripting. And in this case, you can see here where the search value gets appended to a query parameter. If you can see that, I know it's small, but then they thought what typically happens is why you see a lot of emails with spam. Attacker finds something like this on a trusted web page where they can insert code. Now they have a link they can send to somebody. And if they get them to click on it in an email or whatever it is, okay, now they go to that website. Maybe it's a trusted website, but has a query parameter that's able to inject some JavaScript, and now it's doing something malicious. So that's the reflected cross-site scripting case. So that the inserting of a script tag like that's probably the most common one that's sanitized. So it's kind of a cat and mouse game with hackers trying to find new ways they can inject JavaScript, and then the various sanitation libraries trying to prevent that. So just to give some other examples of other ways JavaScript can be inserted, like here's an A tag. If you were to able to get that injected into the document, well, you could put your JavaScript in the on mouse over event. When somebody hovers over that A tag, then it's going to run that JavaScript. Or here's an image tag, and then you put a bad URL for the source, and then it triggers the on-error handler, and then that'll run the JavaScript. So there's lots of different examples. You can get online. There's hundreds of these. And then so there's always new ones coming out, which is why it's critical to patch any libraries you're using, because those will be found, and then a lot of times things are patched. But that can lead to other vulnerabilities if you're not patching various libraries you're using. Okay, so the most important piece around this is prevention. So we have these four methods: sanitizing our user input, encoding, using safe syncs, and content security policy. So sanitizing consists of three things: filtering any unwanted or potentially dangerous characters, so looking for specific values and then pulling them out. Validating, you can validate your user input conforms to an expected format, like an email or a number, for example, or a certain regex pattern. Or encoding. And here's a way to convert characters into a safe representation. So in the example of that script tag I showed, we can HTML encode the angle brackets, and then when this is inserted into the DOM, it's not going to be interpreted as code. It's going to be treated as plain text. So then it won't get executed as code. So to go back to my example, if I encode those values, I'm going to encode it this time, and now say I insert that same script tag. Now I can see it printed just fine. It didn't execute the code because it interpreted this as text instead of an actual script tag. All right, any questions on that so far? All right. One of the most widely used libraries for sanitizing user input is one called DOM Purify. It's the one I use. How this works is it's just a function you call on any user input, and then it's going to sanitize it for you. And how it works, it's going to filter out any dangerous tags. You can get on their repo and see all the whitelisted tags that it deems are safe. It's going to remove any event handlers that could potentially run JavaScript, and then it'll block the JavaScript URLs like this. This is an older syntax called JavaScript URLs that can be used to execute code. I'm a React guy. I know not everybody is, so I made this presentation to be just to be useful for any web developer. But in the React space, we get encoding out of the box. So if you're using React and you're inserting user input in your JSX, it does that same encoding out of the box. It'll then encode certain dangerous characters into to their safe representation, so they're treated as plain text. But in the React space anyway, one thing to know is if you're using like dangerously set inner HTML, that will not do the encoding for you. So which is why they specify, hey, this is dangerous, only use it if you have to. And if you are using it, you should be sanitizing because you're not getting that out of the box sanitization that you get elsewhere. All right, any questions on that before I move on to content security policy?
So DOM Purify, would you be running that client side or server side?
You can do both. There's one, I use a library called Isometric DOM Purify, so you can run it on both. But yeah, that's another question I got the first time I gave this talk is when to sanitize, because I feel like you have to sanitize on the back end because somebody could just call any API with an API client. And then you probably should also sanitize on the front end, especially if you're going to insert that user input into the DOM. But yeah, to answer your question, yeah, you can use it on both. All right, so another tool we have to prevent cross-site scripting and other things is a content security policy. So a content security policy is a set of instructions that your web server is going to give a user's browser on what is and is not allowed on your site. So it's a set of directives that you supply we'll go through a bunch of different directives. Here's where I can get my JavaScript from. Here's the client-side API sources I can call, form submissions I can do, and then the browser will enforce that on your behalf. So typically how we do this is we supply it in the content security policy header that's sent with the document, and then the browser will enforce it accordingly. Another way you can do it is inside the head tag with a meta tag. I've never done this. Typically, what I've seen and what I've done is the content security policy header. But here's what a directive looks like. So this is specifying where you can get your JavaScript from. So you're saying self, so the origin that's hosting the web page, and then here's another origin that you're allowed to source JavaScript from. And everything's assumed to be HTTPS unless you specify HTTP. It's just going to assume HTTPS, so you don't have to specify that if you don't want to. So some important directives from a security standpoint. The default source, this is a fallback, so there's a lot of different directives, and if you don't specify them all, well then it's going to use the default source as a fallback. So you'll want to keep this one narrowly scoped, and then you can open up the other ones like for JavaScript, for images, for client-side API calls, then you can kind of control those separately and open those up as needed. Frame ancestors, this is another one that can be used to prevent clickjacking. So we'll talk more about that later. I have a whole section on that. But the safest option for this one is none. But we'll come back to this one later. That one will make more sense. Eval and inline script. So just by using a content security policy, it's going to prevent the use of inline scripts and the use of the eval function unless you opt into it. These are, and that's because these can be used for cross-site scripting. That's what I showed in that example for that demo for cross-site scripting. That was an inline script attack. I was inserting a script into the document there. So just by not opting into unsafe inline, I could prevent that. And then report URI. This is an option you can define an endpoint for logging. So if your users have, anytime something's blocked on the client side, it'll throw an error, and then you could have those sent to this logging endpoint so you could see if maybe more things are getting blocked than you had anticipated. Here is an example content security policy. just showing, okay, here's a fallback for all other directives. The script source, this is where I'm allowed to source my JavaScript from. Frame answers set to none, which will prevent clickjacking. Again, we'll come back to that. And then we're also specifying where some images can come from. So self being the same origin, and also this CDN that we trust. And then here we specified a logging service for that report URI. All right. So another thing I want to show is here's a real estate site I've worked on, just something like Zillow. And I'll show an actual real-life content security policy. And I blew this up, so hopefully you guys can see it pretty well. So here's one where, okay, so I have a default source. The fallback is set to self. I have some locations where I'm allowed to source my JavaScript from. I had to use unsafe inline to opt in to inline scripts because of some analytics that needed inline scripting. Let's see here. I have this connect source. That's where I'm allowed to make client-side API calls from. So I specify some domains there. And then another one that we haven't talked about yet is the frame source. So sources that are allowed to be framed by my site. So I'll give an example of why that comes in handy. So here's a page when you're, like on Zillow, if you're viewing a house for sale, right? Here's an example of that. And what's kind of cool is that some of them have these 3D tours where you can actually walk through the house. It's kind of cool. Well, in an example like this, all I'm doing is I'm showing somebody else's site inside of an iframe. And this information comes to me from a listings API. Well, I don't have any control of the data coming from that API. It's actually probably inputted by a realtor. So I don't want to just show anything here because that's a potential vulnerability, because then if I was allowing any URL, I could potentially be showing something malicious. So that frame source directive will say, okay, only these 1, 2, 3, 4, whatever, however many site or origins are allowed to be framed at my site. Everything else will be blocked. Let's see here. Let me go back. Yeah. All right, any questions on that? All right, cool. All right, so the next vulnerability I want to talk about is cross-site request forgery. But before we do that, we'll talk about cookies, because the behavior of cookies is critical to understand why cross-site request forgery works. So most of you guys are probably familiar with cookies, just small pieces of data stored on the browser we use to track clients. They're stored as key value pairs. Typically what happens is that our server will use the set cookie header to set cookies on in the client, and then the browser will send that cookie back on subsequent requests to the same server. So the important thing to know about cookies for our discussion here is that they're sent automatically whenever future requests are made. It's going to send back cookies associated with that same site. Some attributes we have on the cookies: expiration dates. You can either expire it at a specific time, or you can set a max age, like 1 day, 180 days, and then when it expires, the browser will delete it. If you don't set a expiration date, they'll last for the duration of the session, so whenever the user closes that tab or window. You can't delete cookies directly, but if you had a cookie you wanted to get rid of, you can set the expiration date to a date in the past, and then the browser will delete it. Kind of a weird quirk of how they work. Some other attributes you can use are path, so you can narrow the scope to a specific path on your site. Secure is an attribute you can set, so the cookie will not be sent over HTTP. It'll require HTTPS. And then the HTTP only attribute will help prevent cross-site scripting, because this is going to prevent the cookie from being read via JavaScript. So if it's like an authorization token, for example, and you have no need on the client to read that value via JavaScript, you can set this attribute, and then if an attacker did get a cross-site scripting attack to work on your site, they wouldn't be able to reach in and grab that token value because you have HTTP only. It's only going to be sent on requests. JavaScript doesn't have access to it. And then the one relevant for cross-site request forgery is same site. This controls which sites your cookies will be sent to when you're coming from cross-site. So you have 3 options: strict, lax, and none. So a cross-site request is, if I was on Google and then I click a site like Facebook, for example, that's technically a cross-site request because I'm coming from Google going to Facebook. So if I have it set to strict, I wouldn't send my cookies in that case, but if I have it set to lax, I would send the cookies for GET requests. That way, it's a better user experience because that way, if I'm already logged in, I'll stay logged in. I won't have to be sent to the login page. So we'll come back to this. This was added in about 2020 timeframe, and the whole purpose of this was to prevent cross-site scripting attacks, which we're going to talk about next. Sorry, did I say cross-site scripting? I meant cross-site request forgery. All right, cross-site request forgery. So cross-site request forgery, an attack that tricks an authenticated user into making an unintended request on a web application. So this kind of attack is, imagine I'm looking at my bank account. I can see all the requests that it's doing to do a bank transfer, for example. If I wanted to forge a request and have your bank account transfer money to me, that could potentially be possible if the only thing that's I need is your cookies. If we're using cookie-based session handling, if I had your cookies, I could make that request on your behalf. But I don't, but as we discussed previously, the browser will send cookies on any subsequent requests for cookies that it has. So for a cross-site request forgery attack to work, it has to have a relevant action, something like changing a password or making a bank transfer, cookie-based session handling, and then no unpredictable request parameters. And we'll come back to that third one. That's a means of prevention. But essentially, if I can get your browser, trick your browser into making this request, and then it sends those cookies on your behalf, well, then I could potentially do a cross-site request forgery attack and get you to make a request that you never intended to do. So here's a simple diagram. So if an attacker forges a request for a fund transfer, and then they are able to embed a link, embed that into a link, say it's a GET request, and then they get you to click on that. You click that link, it opens in your browser. Your browser has those cookies because they're authenticated, they're already logged in, and it sends those along with that request, and then it sends their money to the attacker's website, for example. So things you can do with cross-site request forgery. We already talked about fund transfers, change email password, post malicious content on social media, change user settings, maybe to disable security features like two-factor, e-commerce fraud, or delete important data. So the most vulnerable endpoints to this now, especially with the introduction of that same site cookie attribute, are GET endpoints. These are the most common and the easiest to attack. That's because you can easily send these malicious links via email, for example. So cookies with that same site attribute set to lax are still sent with GET requests, not with post requests or other requests, but with GET requests, cookies will still be sent, which is why you don't want to have any state-changing requests use GET requests. That should only be for fetching data. So you could do that, or you could also embed a GET request in like an image. So if you get a person to visit a web page and you have like an image tag like this, you could put the URL in the source, and that won't actually produce an image, but it'll call this request, and it'll send the cookies along with it potentially. So there's a lot of ways that GET requests can be vulnerable. Post requests can still have cross-site request forgery, but they're a little more complicated. You'd have to here's an example where you could have a form submit a post request and have it automatically submit when a user visits a page. But that same site attribute will save you if it's set to strict or lax. Your cookies will not be sent in this case. So prevention, stateless GET requests, header verification, CRS tokens, and same-site cookies. We'll talk about this a little bit. So I already kind of talked about, so stateless GET requests, if you don't have any GET requests making stateful changes, you're going to prevent a lot of cross-site request forgery. It becomes a lot harder at that point. So GET requests are the most vulnerable because they're the easiest to attack because there's just less defenses around them. GET requests are really, their purpose is to fetch data, to get data, to not change any data. Header verification, this is a simple first line of defense where you could verify the refer header that's sent on all requests, and you could verify that's coming from a trusted origin. So if it was cross-site, you could prevent it. It does have a low chance of being spoofed, so it's not foolproof. The best defense is cross-site request forgery tokens, CSRF tokens. So this is where you inject some randomness into that request. So if I'm an attacker and I'm looking at how these bank transfer requests are looking, The only way I could really forge one is if there was no randomness to it. So here's where we inject kind of a random token that the attacker couldn't predict in advance. So that way I can't forge a request on your behalf. So I'll have maybe a token that then that'll be sent with every request that's then validated by the server that will be unique to each person. And then that same site attribute, using that, setting it to strict or lax, will then prevent cookies from being sent on certain cross-site requests. Any questions on cross-site request forgery? All right.
A lot of frameworks will generate those CSRF tokens for you automatically, right?
I think so. I mean, it doesn't have to be that hard. I think there's a double submit pattern that I've seen a lot where it's kind of nice. So how it essentially works is this way you don't have to track the token on the server side. You can send it with a cookie and have it sent with the request as a value, and then the server just validates those two values are the same. So that way you don't have to have a database tracking these CSRF tokens align with these users. It's kind of an easy way to do it because it kind of sounds like, okay, I'm just sending that value twice, but it works because the hacker can't look, it doesn't know your cookies. And so the cookies still remain private to you, and then it sends it to the server and just validates that the cookie matches the CSRF token, header or wherever you put that value in the request. But yeah, as far as frameworks doing it out of the box, I imagine there's got to be a lot of libraries that do that for you.
Java ones do at least.
Oh yeah? Okay. Cool. All right. Next one I want to show is SQL injection. This is probably the most widely known vulnerability. It's been around for many years. It's still an issue, so I'm going to hit it as a high level, and we'll talk about prevention. But I think most people kind of know a little bit about SQL injection. But this is where we're basically inserting malicious code into SQL queries. So how this might work is if user-supplied data on a front end is then used in an SQL query, then attackers can insert malicious code and do maybe potentially access sensitive data. They can bypass authentication, modify data they shouldn't be able to, delete data, execute admin commands, plant malware, maybe for a future cross-site scripting attack. That can all be done with SQL injection. So how it works, there's a lot of different examples of this. I'm going to show a pretty simple one, but imagine this is a login form, and here's the query that's using the username and password here. So here's the query. Select from users where username equals the username supplied value and password equals the password supplied value. Well, in this case, the user supplied a value with the ended in quote -- so then it looks like, so then it comments out the rest of the query. So now the query just becomes select from users where username equals admin. And it doesn't actually also validate the password. It doesn't validate the password anymore, and now the user's logged in. So that's a simple one where the user injected some code there to then alter the query. So now it's no longer safe to run, and they're able to log in as admin. So there's probably hundreds of different means for different SQL injections that need to be sanitized out. Here's a couple other examples. If you ended it with a single quote, and then you could drop a whole table, you could change the password for the admin user, for example, or even send a file to your own server. So around prevention, we have input validation and sanitization, which we talked about. Principle of least privilege, another easy one, like maybe you shouldn't be able to drop a whole table in the production server, for example. But the one I wanted to show was parameterized queries, because I don't do a whole lot of SQL, but I see parameterized queries in other places too. So a parameterized query is essentially a way for you to separate the user-supplied data from the query. So that way you eliminate the possibility of the user-supplied data to be interpreted as code. So here's an example from Postgres. So here's the query that we're specifying in advance, and then here's our parameters. Here's $1, $2, and then here's the user-supplied values. So now whatever they input, it's not going to change the query. So we're going to supply them to our database separately. So now these values aren't going to be interpreted as code. It'll only be interpreted as data. So like I said, I don't do a whole lot of SQL. I haven't in the past few years, but I'm working on a side project now with the Sanity CMS. They have their own query language called Grok, and they use the same technique, parameterized queries. The syntax is different, but same principle. You're separating the query out from the user supplied data. All right. Next, I want to talk about clickjacking. So clickjacking is an attack where a user would create a web page and get you to click something you didn't intend to. And so here's another one where it's just easier to see an example. So if we go to, so imagine here's a legit page. I just have a simple email form. This is on your favorite e-commerce store, for example. So if the attacker wanted to do a clickjacking account and change your account emails to theirs, maybe they create a web page like this. They embed that form as an iframe, and then they set the opacity to 0. And then they put something like this on the page, and they say, hey, click this for your free prize. So you click that, but when I change the opacity of that iframe that was hidden to back to 100, now I see that I clicked on a button I never intended to, and I changed my email to the hacker's email. So it's just it's a sneaky attack where they're just getting you to, all they get, so they embed something in an iframe to a site you're already authenticated on. So it'll show you as an authenticated state. Here's your email on your account, for example. And then they just need to get you to click somewhere that you didn't intend to, and now it changes the email to theirs. So that one, it's kind of a pretty simple attack, but it has a simple solution, and that's back to that frame ancestors directive in the content security policy. If you set that to none, then nobody's allowed to frame your site on theirs. So nobody would be able to put your site in an iframe on theirs. And if anybody does have a legitimate need to frame your website, well, then you can, on your content security policy, you can specify the origin that's allowed to frame your site. Everybody else will be blocked, and that prevents clickjacking. Any questions on that one? All right, next I want to talk about tab nabbing. So this is an attack where an attacker would manipulate an open tab and basically redirect it without the user's knowledge and probably bring them to something, to a malicious site, for example. So here's another one where it's good to see an example. So we'll look at tab nabbing. Okay, so imagine I'm on a website, I'm on the attacker's website now, and I click this link, and it goes to maybe my favorite e-commerce site. So this is a legit page, and now I'm not going to click anything, and after a few seconds, I'm going to be redirected to a malicious site. So I didn't do anything. You saw I originally opened up a trusted website, but then I got redirected later. So what happens in this type of attack is that it's going to bring the user to a legitimate website. But what happens here is that the first tab in the hacker's website maintains control over the second tab. It has an object reference to it, and then after a period of time, it then redirects it to another site. So it could be something malicious. So the idea here is maybe it brings you to your favorite e-commerce store, and after a period of time, it redirects to a malicious site that looks just like that e-commerce store. It gets the user to enter their username and password or credit card information, whatever it may be, and then it sends it to the hacker. But how that works, here's a simple code example. Okay, so that link, it opens up a new tab here, and it retains a reference to that window object. And then later, I say after 5 minutes, and it was 5 seconds in my example, then it just changes the location of that window object reference to somewhere else. So again, a pretty simple attack, and it's got another simple solution. So in this one, there's a cross-origin opener policy header. You can set it to same origin, and that'll prevent any pages other than pages from your same origin from being able to have reference to that window object. So it'll prevent the tab napping type attacks. All right, any questions on that one? All right, cool. Oh, go ahead.
Should any of these just be default behavior?
That's the thing, yeah, and that's what I learned going through this. You're right. If we were to build this all today, I think you're right. They would default to the secure option. I think the problem is over time these things got added and they didn't want to break the web, and you know what I mean. So when browsers started enforcing this, you kind of have to opt into the secure methods rather than opt out.
Are there legitimate use cases of tab nabbing? Like I've never seen.
There's probably sites that use that window object reference. I don't know, but yeah, but
We use that at work.
you do? What for?
So in our case, our applications generate, like we have different tabs. And we want to be able to, if I make a change to one or I select, like say, a piece of equipment in one tab, to then update the data that's on the other tabs that I've changed.
I got
So
you.
it needs to be dynamic enough that you don't have to like resubmit the same thing on a whole bunch of like new tabs that you've opened up.
Okay, I got you. But it's all on the same site. It's not
Yeah,
cross.
You can still specify which, it's like our domain.
Yeah, it's all our
Yeah.
host in that case.
Yeah, that makes sense. But yeah. To answer your question, though, I think that's what happened, though. They added all these things over time, and then so there's a lot of them you just have to opt into the secure way, which if we built it all from scratch today, we just make that the default.
It's like with Portal, you got to use strict everywhere. Like, why do you got to do that?
Use
Oh.
case.
Seems like you had a master header that just says, I want standards past date or something.
Oh, yeah,
Option into HTML 2025 says,
right.
Like Perl 5.
like a revision or something.
But yeah, with that frame ancestors that prevents click checking, same thing. You kind of got to opt in. You have to specify none, otherwise it'll let anybody frame your site. So another way, another one, you just kind of got to opt in and know about it, and that's easily preventable. All right, cool. Okay, so in secure application configuration, we've already talked about content security policy and cookies. The other ones I wanted to hit on was cores, headers, and framing. So cross-origin resource sharing. This is a browser-implemented security feature to relax the same origin policy. So the same origin policy is enforced by our browsers, and this prevents, like say you have your bank and you have Facebook open, you're authenticated in both of them, you have access to data in both of them. Well, the same origin policy is what prevents, maybe Facebook from viewing your banking data and your bank from viewing your Facebook data. It kind of has a separation there. And one of the things that the same origin policy does is it would prevent client-side API calls to different origins. Well, the cores is a way for us to relax that, where your API could say, okay, no, we're going to allow these other origins to view the data from this API, for example. So this is all enforced by the browser, but essentially allows you to relax that same origin policy where appropriate. So when it comes to the cores headers, the idea is just don't open them up any larger than you need to. So you could allow all of the origins, wildcard, just only add the origins that have a legit use case to view this data, only specify the methods that are allowed, the headers that are allowed, because that can prevent header injection attacks where people can inject code into headers and get the server to do things you may not want to, and then the credentials, only have them sent when needed. Some other headers you can set on your web server. Strict transport security specifies the page to be loaded over HTTPS. The next two, X content type options and content type. This allows you to prevent certain cross-site scripting attacks where, say you had a site where you allowed users to upload images, for example. There are certain cross-site scripting attacks where I could maybe have a JavaScript file that I have end in .jpeg, and then the server might see it, or the browser might see it and say, hey, this doesn't look like an image, this looks like a JavaScript file, I'm going to execute the JavaScript. Well, these options let you kind of prevent that by saying, okay, don't sniff, don't try and guess what the type of file is. I'm going to tell you exactly what it is, and then if you specify the content type every time, well, then it eliminates attacks like that. So now if you say it's an image, you should try and render it as an image rather than execute the JavaScript. So these are easy ones you can set on your web server on every resource as well. All right, next one around framing. So if you have reasons to, if you have other users' third-party content embedded in an iframe on your site, like I showed that with that example with that home walkthrough, another way you can really narrow what's allowed in that iframe is using the sandbox attribute. So essentially it really locks things down, and you have to opt in to being able to execute JavaScript. You have to opt in to be able to do form submissions, it'll disable the browser APIs. I think there's also some attacks, I'm not sure if they're still possible, where an iframe could do a top-level redirection and then maybe redirect to a malicious site. But point being that if you add the sandbox attribute, it's really going to lock it down, and then you're going to have to opt into things. So like on that one example I showed, let me go back to that. I think I had to opt into JavaScript even. You add that sandbox attribute. Come on. Here. Where are we at? Here we go. So I add the sandbox attribute, and then it'll block JavaScript entirely until you then say, okay, allow scripts, for example, which pretty much everything needs JavaScript. But it's going to block all that, and then you basically open it up to whatever you need. All right, so now a few tools you can use to help keep your application secure. So the first one, software composition analysis tools or dependency scanners. These are tools I think everybody should be using if you're using any third-party libraries, which we all are. So all of our dependencies, those dependencies have their own dependencies, so on and so forth, built on top of various third-party libraries. And nobody has time to go review all that code. So there's tools that do that, and they report back any security vulnerabilities to us. One of those I'm going to show is called Socket. So there's a lot of tools like this, but essentially you can integrate them and say GitHub, and so every PR it'll run a security scan, and then it'll spit out a report. So here's Socket, and then it'll go through and it'll look at your manifest, so your package lock.json file. It's already scanned all these packages, right? And it's just seeing, okay, here's the packages you're using, here's the versions, here's any vulnerabilities we've found on them, and then it'll spit out a list of vulnerabilities sorted by the most severe to least. So it'll find things, okay, in this version of Next.js that I'm using, there's an issue here where authorization, there's an issue where you could potentially bypass authorization if you're using that check-in middleware, for example. But these are really handy tools that'll tell you what vulnerabilities are in those package versions, and a lot of time all you need to do is patch to the latest version. Another cool thing about Socket, if you go to socket.dev, it's kind of cool if you're ever looking for a new package. For those of you that are using NPM, you can get on there and you can get more information than you can get from the NPM site on specifically around security. Like here's a package, and it'll tell you various things it found when it scanned it that could be potentially dangerous. Like this one's using environment, it's reaching in and using environment variables, and so on and so forth. This one doesn't look like it has too much, but it also gives you a kind of a dashboard of what it found during its scans, and this is all free. So yeah, it does have a paid version, but first I think they do have a free tier as well, and that's what I've integrated here on some of my personal projects. All right. The next set of tools are SAST, or Static Application Security Testing. So the previous one scans our dependencies. This one scans our code. So our code base will get scanned by these. These are effective at finding unsanitized inputs, hard-coded secrets, potential cross-site scripting vulnerabilities, and there's a lot of them that'll help with code quality too. But these are really nice. They're easily integrate into your pipelines to say scan your code on every PR, for example. You do have a lot of false positives, but you can get a lot of feedback pretty quick. So the one I'm using at my client right now is on GitHub, which is really nice. The one I'm going to show today is SonarQube, just because they have a free tier. So I have this integrated into my GitHub PRs as well. So on every pull request, it'll do a scan. And some of the things, so just to give it some examples, it's reviewing the code, looking for any potential vulnerabilities. It found that this one, hey, this is using HTTP, upgrade to HTTPS instead. And here's an example where you have a false positive, where it found, hey, I'm using math.random. I think what I'm using it here for is just to inject some randomness on the image that's shown. Well, it's saying, hey, if you're using this for like a CSRF token or any sort of security means, this isn't really random and it can be predictable, so don't do that. So an example of a potential false alarm there too. But again, a lot of good data out of these, and they're really easy to integrate into your pipelines. The last one is dynamic application security testing. So now we've scanned our code, we've scanned our dependencies. These tools will actually scan your application in a runtime context. So once you have your application deployed somewhere, you can use these tools to do a scan and find various vulnerabilities. And actually run attacks on your application. So these tools, this is where you kind of cross into penetration testing as well, but you can use them in pipelines to scan your code as well. Again, a little bit harder because you have to have your application deployed and then run the scan, and they're more time consuming. And again, same with the other ones, you get some false positives, but it'll simulate real world attacks, but it doesn't have any access to your code, and a lot of them are dependent on crawling. So if you have some endpoints or routes that are not visible from a crawling standpoint, they're not in a sitemap or not in a menu, well, these scanners may not see it, so you may have to help them out a little bit. But the one I'm going to show is called Zap. This is an open source free tool. So again, yeah, totally free. Anybody can go download this for free today and start using it. So an example I'm going to show, I pointed this towards that real estate site I showed earlier, and then I let it run. And I mean, it took like a half hour or so, but it scanned 5,000 plus pages, and then it spat out a bunch of alerts. And you can create a nice report from this too. I know it's kind of small, hopefully you can see it, but it gave a lot of useful information. So in a passive scan, it's not actually attacking the pages, it's viewing them all. And then from there, you can get a lot of useful information on maybe potential content security policy issues. It called out, using unsafe inline, unsafe eval. I've since fixed this. Some false alarms here where it said some PII disclosure because it thought I had a credit card number, but really this is just a slug coming from the API, I believe. So again, some false alarms, but a lot of good information on various headers that could be set or that were missing, or improvements that could be made to content security policy. It even found a vulnerability in a library because from the headers it could see the Next.js version I was using, and it called out an issue it found there. But again, it's not going to have access to all your dependencies, so because it's looking at it from a runtime context. But a lot of good information there. But then you can also run it into attack mode, and that's where it'll actually try and attack your app and look for cross-site scripting or look for cross-site request forgery. But then there you have the potential of it actually altering the database or doing harmful things. You'd only want to use that in maybe a dev or a staging environment, not point it at your production app. Let's see here. Any questions on Zap? Yeah, go ahead.
I didn't have any questions about it because it's one of my favorite tools too.
Oh yeah, cool.
But I had a couple comments in that some people in this room might enjoy. It has a scripting engine built in. And so
Okay.
you can create your own custom scripts in Zap. If you click the plus at the top left,
Right here?
I think so, yeah. There's various scripts that you can include. You can write your own scripts in Java. You can write scripts in Java script flavor that is runs because it's all a Java app. But you can also, I think, script in Python too.
Nice.
So you can capture requests and you can then repeat them and then script around them too, which is really powerful and it's really cool stuff. So yeah.
Nice.
I like that you were using Zap and not Burp Suite.
Oh yeah.
Burp all the time. I'm like, it's overrated.
Oh really? Yeah. So Burp Suite's probably more commonly used, but it's paid. So pen testers out there are probably using Burp Suite, but Zap is like the free open source version. But yeah, and they also have a ton of add-ons too, which I haven't dove into, but they have a whole section of add-ons you can add on for specific use cases, which is pretty cool.
You were talking about helping it out with discovering your API. I think they put into the open API definitions on GraphQL as well.
Yeah.
We have it set up to basically try and hammer our whole GraphQL point.
Nice. You're using Zap?
Yeah.
Cool.
You can also run it in headless mode, so you can run it with your CI pipelines.
Okay.
So you can have it. I think there might even be a GitHub action to run Zap, so on commits you can target your app.
Right.
So.
Yeah. I haven't got that set up on mine, but I know you can do that, especially like a passive scan, right? And then spit out a report.
Yep. And it also has its own API, so if you want to run scripts locally to plug into it, you can do that. It's just
Nice.
very flexible. It's a cool tool.
Oh, very cool. Yeah, good deal.
So this is a paranoid question.
Sure.
If this is a tool that is finding vulnerabilities in your website, how do you know they're not using those vulnerabilities against you?
Good question. Yeah, that I don't know. Yeah, I mean, this tool did have an association with OWASP. So anyway, I mean, yeah, but you're right. How do you know you can trust it? That I don't know. So yeah.
All right.
They can also run it on your site themselves.
Right.
Yeah.
Because some of these other tools, we use scanning tools at work, but it's isolated. It's within our network. It's not something running from somewhere else. But this is going to your website and finding vulnerabilities.
Right. Yeah. Sure. So you're worried about them taking that information and sending it back to.
I mean, if I were trying to trick someone into revealing vulnerabilities, I would do it by creating software that is designed to help them find the vulnerabilities.
Right.
But if the company is, this is what the company is and we stake our reputation on it.
Right.
They go bust if that's.
Right. I just don't know what this company is. I've never heard of this before.
Yeah.
You could just look at your network traffic too, sniff all the packets to see if they're going where it's supposed to.
There's a whole bunch of companies that scan every IP4 address every day. So if you actually look at your logs, they'll hit you every day and have a nice little user and it says, hey, contact us if you want us to stop.
Oh yeah.
We're looking for vulnerabilities.
Nice.
Interesting.
Oh, cool. All right. So that's about all I had. I'll wrap with this slide. So on resources. So this is the best book that I've personally read on the topic. It's called Web Application Security by Andrew Hoffman. There's 2 editions. Get the second edition because it's the most up to date. Port Swigger they're the people behind Burp Suite. They have a lot of good free resources on their website. And then OWASP.com, again, has a ton of good resources and checklists, and their top 10 list as well is pretty good. Yeah, that's what I got. Here's the slides. If anybody wants them, you can easily go download them. So, but that's it. Thanks, everybody.